You're listening to The Interactome, a podcast by a group of young researchers who want to connect you to the world of science by sharing their stories and perspectives. Just in case their bosses are listening, they want to remind you that the opinions expressed here are their own. They also want to remind you not to take anything they say as medical or professional advice, as they are not doctors. Not yet, anyway. Stay tuned about that. And, without further ado, welcome to the Interactome.
Hello, Interactome listeners. Welcome back to another node today. We have a very interesting and exciting episode that I'm sure you'll all enjoy, but I'll let Natalie take away introducing our special guest for today.
Hi everyone, it's Natalie. Welcome back to the Interactome. Today we are joined by a very special guest, one of my very dear friends from undergrad. Her name is Bridget O'Connor, and she's going to walk us through all things microbiology. So welcome, Bridget.
Yay, welcome, Bridget.
Thanks,
Woo!
guys. I am so excited to be doing this today. I love the microbiome, and I love science, so this is very exciting.
Well, you've come to the right place, let me tell you.
Good.
Where we love talking science, all that stuff. So why don't we start off a little bit about your background? So maybe tell us where you went to school, what you studied, and why.
Yeah. So like Natalie said, we are friends from undergrad, and so we went to, are you cool if I say where we went to? Okay. All right. So we both went to UMass Amherst, and we graduated in 2020 during the pandemic, which was super fun, especially because we were both studying microbiology. So
it was quite the time.
It was quite the time. But it was quite the time. It was a lot of fun. And microbiology was a lot of fun to study. Kind of why I got into it was, and for like, if anyone who's listening to this knows me, this is about to be the most me explanation ever. But it was really because I was going through a bit of a mid-college crisis, as we all do. And I was like, oh no, I don't actually want to go into medicine. Had like a panic, and one of mine and Natalie's really good friends, she was just like, why don't you just switch into micro? And I said, okay, I trust you with my life. So I switched. My major from biochemistry to microbiology. And I remember during the first lab that we were taking as a course, I was just looking in a microscope at these cute little skin bacteria cells, like literally just a swab off your hand or something like that. And I was like, these are the cutest things I've ever seen in my life. And I want to just look at these forever, basically. And one of our professors overheard me saying that, and she goes, you should be here. You should be here. And yeah, it kind of just, I don't know. I've always found bacteria, especially the mammalian cells as well, they're cute, but bacteria hold a really special place in my heart. And then once I learned about like all of the potential benefits they could have, that really, I don't know, that kind of solidified it for me. I was like, okay, I like this. And, I actually have now moved on from microbiome research, but it really will always hold a really special place in my heart. And I'm glad that it's becoming a topic that more and more people are interested in.
Yeah, that's great. I'm glad you found your calling.
Thank you.
This is something, I guess I forgot to introduce myself at the very beginning because I was just so excited to talk to Bridget. I've been waiting for this episode for a while. But listeners, my name is Maia. I am a grad student studying molecular and cell biology, and I totally get what you mean when you look through a microscope and you see like really cute like little things. I work with yeast in my lab, so when Bridget's face just got so they're super cute. When you look through the microscope, they're just like round and happy, and they look so squishy, and I think that they are just adorable. I said verbatim, like, these are so cute when I was like first working in the lab, and my mentor was also like, I think they're cute too.
Yeah, I think that there's such a you know, I've talked about this before with a lot of my friends, a lot of my colleagues, and, you know, growing up when, especially in middle school, I think that's like the peak time during a lot of our education where it's kind of like you have to, or it seems like you have to pick between like the sciences and the humanities or arts. And for me, like I love to paint, like I'm an artist at my core, but I was encouraged to go down the science path. And there's a lot of me that I don't want to say like regrets that decision, because I don't regret that decision, but I wish that I knew at the time how much the two can be integrated, because there's so much beauty in science, and there are a lot of people who are starting to kind of integrate those things down. I think it's so exciting and it's so sweet because they're beautiful, they're cute, and they're like they're with us literally all the time. So we should appreciate them.
We're never alone. We're surrounded by cute little friends everywhere. But it's an interesting dichotomy that you bring up, because I feel like you're right. Like people do kind of like draw like a hard line between like, you know, your left brain and your right brain, sciences and humanities. But I really do think that there's a lot to be learned from sampling from both of these different kinds of disciplines.
Yeah, for sure. And I think that when Natalie and I were talking initially about like some of the things we would maybe want to touch on during our chat today, one of them was kind of on this like art and science situation. And every year, one of my favorite things to see is the association of ASM. What is it? Association.
AASM? American Association.
I'm trying to think what the SM is. So
Society of Microbiology.
American Society of Microbiology. Wow, I just never say that out loud. Like the full name,
acronyms.
But acronyms, yes. So ASM, they put out every year this really fun contest for, I think, undergrads, I think even high schoolers, like as young as high schoolers can submit, but all the way through like postdoc, like industry researchers, everyone. And you can submit your agar art. And so, yeah, I love it. People are so creative, and it's really fun to see how people are able to manipulate whatever organisms they're working with, because it can be bacteria, it can be fungi, it can be a lot of things, and people are so creative. So that's like my favorite part of the year, to be honest.
And those come in like crazy colors. I've seen examples of agar art online. Like
exactly.
My lab actually does like something, I guess, like kind of related to microbiology, but like but kind of like in an informal way. We have like a annual pet show where we take like all of these like different contaminants that we find in the labs, and not only just like fungi or yeast, but like weird bacterium and things like that. So we take like all the different contaminants, and we also swab like surfaces for like interesting things. So we like go outside, we like swish around in the creek, we like swab like the tree bark. Like a lab mate like held up like an agar plate to like a squirrel and was like trying to get it to like put its little paws on the thing. So we like let those grow like in our warm room so that they're happy, and then they like come out with like funky colors and like different shapes, and some of them like smell a little weird. But then we have like a like contest for like, oh, whose pet is like the nastiest, or whose is the cutest, for example. And in particular, this is like a running like joke or like fixed meme in our lab, where we have like one of the most famous pets that was isolated by my lab mate was one called Garfield, because it was like bright orange, and it also ate all of the other molds like on the plate, so he was hungry. But
oh my God.
Lots of things to learn from the world of microbiology.
Definitely.
I'm gonna start calling all the microbes that live on my person my pets.
Oh God.
My pets. My
pets.
My thousands and hundreds and millions of pets.
You're never alone. You are never alone, and it's a comforting feeling at times.
To some, I think some might also, who are less experienced, might be pretty horrified at that fact. But we're here to demystify that and to make it not scary. So I think too, one thing, Bridget, you mentioned at the top of the conversation is mammalian cells, they were kind of cool, but they didn't quite really strike it for you. What are some of maybe the main differences between human cell biology and then microbiology?
Yeah, that's a great question. Because, especially like until you get into some more specialized areas, it's biology as this big concept, but there are a lot of different subsets of that, of course, and one of which being microbiology. To kind of start with I'll start with microbiology just because that might be a little bit easier. So microbiology is just, as the name kind of suggests, the study of microorganisms. So when it comes down to that, really, we're talking about bacteria, viruses, archaea, fungi, and that's kind of like those single cellular organisms, and how they interact. Well, how they function in and of themselves, so their own physiology, but also how they interact with the environment around them. That can be like, human system or the physical environment, like a soil environment, anything like that. And so that's kind of microbiology. But when we talk about human cell biology, we're talking about the larger cells that are making up our human body. And that is like what's leading to, our skin. Like our skin cells aren't bacteria, right? So we have bacteria living on our skin, and that's a good thing. We're supposed to. That is important. I want to just throw that in there real quick. But the cells themselves, those are skin cells. That's tissue. So that's like on a very high level, the differences between the two. Really just like singular versus multi.
Yeah. So for kind of like scale, bacteria are like really, really tiny compared to mammalian cells, right?
Yes, they are. I mean, mammalian cells are also very tiny objectively, but
also true.
yes, very small.
And I think too, one thing that always strikes me about microbiology is because I used to, and I even like Bridget and I met in the microbiology major, and one thing that was so hard for me to eventually wrap my head around is the fact that, you're talking about unicellular, one cellular organisms. I used to see kind of, oh yeah, the bacteria have their cell, but they only have one. But if you kind of zoom out, that's not the right way to look at it. Bacteria are that one cell. And I always thought that was interesting because growing up, or when you're learning in science class, it's kind of like, oh yeah, the cells on your body, like you can't really see them, but they're there, but you're like this other entity. And microbiology is very different from that.
Yeah, and I think, you brought up a really good point too, like in the curriculum that, when people are learning microbiology, kind of backpedaling to, we were talking about agar art. So for those listening, agar art is referring to when people take cultures or samples of, for the sake of this conversation, we're going to go with bacteria, and they put them on these plates of like similar to gelatin. It's kind of like this it's like this jelly. It's like this hard jelly that you want to eat but you can't. Forbidden jelly, like little gummies, and they're in petri dishes, and they have the type of ingredients in that media. Those are going to be feeding the bacteria and allowing them to grow, and also giving them a surface to grow. And so when you're in school and in your labs, the bacteria, they grow up quite a lot so that you can see them on these plates. They'll have different expressions of their phenotypes, so what they're physically looking like, depending on what ingredients are in there. But the fact that they grow up that much that you can see them with the naked eye, that just means that there are a ton of cells. So when we're looking at that, it's very easy for especially a student to have that same train of thought that Natalie was just mentioning. It's like, oh, okay, that's all the bacteria. No, that is a lot of bacterial cells. And it's that phrasing that is so imperative to being able to make that distinction in your head. And it's the same thing when you're looking at samples under a microscope. You are looking at a sample made up of a ton of cells.
And sometimes, depending on the situation, those cells are different types of bacteria.
Yep.
So you'll have kind of multiple, because I think the coolest thing too about the forbidden jelly that Bridget was just talking about, highly recommend you look it up. It's agar plates, AGAR, if you want to look it up. You've definitely like seen them in like the media or like in movies. I'm sure that like you have or whatever on like lab pictures. But the ingredients to that agar is very specific to the kind of bacteria it's going to grow. So because there are so many different types of bacteria, and, you know, Bridget and Maia, let me know if I'm off base at all. There are so many different types of bacteria that it's just like the animal kingdom, right? Some organisms can fly, some organisms only swim. There's some bacteria that can't handle oxygen. So you need to make sure that if you want to grow them, they have no oxygen in their environment. Vice versa. They need oxygen, so they make sure they have that, yada, yada. And that's one of the coolest things I think about microbiology is because you can't see the organism, but using the agar plate and using what you know, you can piece it together. And that's one of the things that I found the coolest.
Yeah, I used to joke when I was doing microbiome research that all I wanted to do was just, because I really did enjoy media development. Because a lot of times we were trying to grow bacteria that there's very little to no scientific literature about. And so it was a lot of trial and error. And the way that I kind of framed it when I was talking myself through it or talking with somebody new about it is I just want to make the happiest little environment for our friends possible. And playing with the atmospheric conditions as well as again the ingredient. Nope.
That's funny because it's media.
The ingredients in the media. Exactly.
Ingredient.
Yeah, playing with all of those things to just make that happy, healthy environment for your friends. It's a lot of fun.
Wow. It's like you're kind of like cooking and trying to get like the perfect recipe for something that our small friends will enjoy, I think.
Absolutely.
I've never baked sourdough, but I imagine it's just like baking sourdough.
Well, yeah, you get the help from the little friends in the sourdough starter, I think.
yeah, definitely. I mean, that's the same with yogurt. You have friends in there.
Delicious. Mm-hmm. Yeah, and it's kind of interesting because, like, you're right that, like, different bacteria do need different requirements. I know, like, sometimes people like to make this funny analogy where, like, if you have, like, a bacterium in the wild versus, like, a lab bacteria strain that just, like, grows happily in, like, kind of very standard laboratory conditions that are, of course, like, different from, like, the wilderness, people kind of like to say that, oh, this is like a wolf and like a poodle, like the wild and the domesticated. But it's cool that like you got to like figure out kind of like what each one kind of needs to study it well. I know that in my program, there's a lab that studies the kind of bacteria that you were, or actually, I think it's Archaea. It might be.
Oh, sure.
Yeah. But they only thrive in environments that don't have oxygen, like Natalie was mentioning earlier. So the people in that lab, I like can't wrap my head around it. Like the anaerobic chambers where there's no oxygen. I'm like, whoa, that's crazy.
Those chambers,
they're just holding their breath all the time.
Like you'll ruin it. You ruin it.
Oh my gosh. So the most of the work that I was doing was actually in those anaerobic chambers for about 4 years. We were working with microbes that were isolated from human guts, so from stool samples. So get that plug in. So fun. But yeah, so our gut does have a lot. Well, you know, it's our gut. There's no oxygen there. Well, there's a little bit. There's like teeny tiny little bits of, and that's
but definitely
that's
like
for like
not
cellular function.
I know. That's
not
just
for
like a thing that I will get itchy if I don't say it. Horrible. It's a horrible thing to say. But anyway, so the majority of those bacteria, they don't want to have exposure to oxygen. So you need to be working with them in those anaerobic chambers. They're really, really, really cool. And just for the sake of clarification, no one's holding their breath or anything like
Cool.
that. They're large, like bubbles, basically, that you put your hands in. There's like gloves that go into the front of it, and it keeps the exterior closed off from the just regular atmospheric levels that we're breathing in, but it allows you to work with the bacteria without oxygen. So it's pretty cool.
Wow, that's neat. Yeah, microbiology misconception number 1. You don't need to hold your breath for an hour at a time. That's so
I know,
neat.
I'm like spreading misinformation, being like, you just gotta hold your breath.
Natalie was like,
Not
in
true.
my undergrad, we just couldn't breathe for the whole lab.
It's okay. Everyone was passing out, but it was for the love of the game.
That only happened like one time, I think.
Yeah, and I did have a question to kind of like wrap up our microbiology 101 here. So to clarify, like we've been talking about like bacterial cells and human cells, but like the cells themselves are pretty different, right? Like a bacteria versus a human cell.
Yeah.
So like what are kind of like the big differences between those two?
Okay, so with those multicellular organisms, and like we said earlier, these are kind of what leads to us having skin cells, hair cells, nail cells, etc., our internal organs. Those have nuclei, and that's a big difference between those versus bacterial cells. When we talk about cell architecture, bacterial cells versus other types of cells in our body, they have a lot of similarities, but they do also have a lot of differences. And those differences are really what ends up being what results in, bacteria versus eventually what makes up your heart versus, the mold that you see on your fruit at the end of the week in your refrigerator after you have neglected it. They all have different functions, and I would say, again, not getting too in depth into those differences. They are all cells, but that is kind of like a very zoomed out perspective of them. Once we zoom in and we can differentiate between the types of cells and what they're eventually going to be, that's when you're going to see those differences.
Yeah, and I think one thing that I'll add too is that when you think of multicellular organisms, the cells in the body of that one organism have to interact. They have to tell each other things. They have to make sure that they're working together to make sure organs and the body is moving. With bacteria cells, they don't necessarily need to communicate like that within their own I guess unit, right? Like as their own being of existence, but they do communicate with other bacteria and other cells. And that's another really big component to microbiology is how cells interact, how bacteria cells interact with other bacteria cells of the same strain or of different strains.
Yeah, for sure.
It's neat.
It is.
And something that I always like get hung up on is that you mentioned, Bridget, that like the kind of like human cells and kind of like more complicated ones have a nucleus. And from my understanding, the bacteria do not have a nucleus, which is like the cellular compartment which like houses genetic material or DNA. So whenever I think of bacteria, I just like picture them kind of like swimming or happily coexisting in whatever environment, and then like all of their DNA is just like souping around inside them, which is like a funny image to me.
I mean, that's what I'm a very, very visual person. And so that was a really big hurdle for me, first getting into microbiology because it's hard to see. And so for a lot of these explanations, I have the same exact things in my head. I just have these little cartoon images and that's fully how I think about that one as well.
Yeah, but it's
all Maia's art. That's all Bridget's brain is made out of.
Or it could be the other way around.
That's true.
Bridget's an artist as well.
Yeah,
Bridget's also very good at art. Shameless plug.
Woo!
Thank
We
you.
we can perhaps collaborate on the title card for this episode. It'll be so
God.
epic. Yay!
I think we should. That would be awesome.
But yeah,
This is such a behind the scenes slay.
Yeah, but I do think there is a lot to learn, like comparing, like, cellular architectures of bacteria versus like human cells and, even like plant cells, different cells that you can find. We can really learn a lot about the differences and similarities, like you were saying.
Definitely. It's really, really cool. And I can understand why people dedicate their lives to it.
Bridget, and a lot of the research that you've been discussing throughout this episode really centers around the microbiome, which is definitely a hot, buzzy topic right now, I would say, in the science and also just kind of in like the global news science space. So would love to get your take on a little bit of maybe like an intro to the microbiome. I think that, and correct me if I'm wrong, but the general narrative isn't as on point as it should be. So maybe what are some of the biggest misconceptions when it comes to the microbiome?
Yeah, for sure. And, for the sake of this being like a science communication podcast, I would be remiss if I did not say that this is a really, in the history of science, this is a really new field. So when we do talk about, or when the media does talk about microbiome research, microbiome science, some things are maybe not being expressed in the most appropriate way, but gotta cut people some slack, because again, it is relatively new. So that's something that I have to say to myself a lot, because it calms me down. But but part of the thing that gets me a little bit riled up that I need to calm down about is the fact that, and I was even doing it during this call, and I was saying, oh, I do microbiome, or I did microbiome research. That's such a vague term. That's like saying I do biology research. Okay, cool. Like what?
You said yes and?
Yes, and.
So there are so many different types of microbiomes. Again, that is a very, like just how we were talking about with cells, that's a very zoomed out, like high level, throwing all the corporate terms, topics. And that's broken down into a lot of different things. For me, I was doing gut microbiome research, but there are plenty of other ones out there. Even just on our bodies, we have our skin microbiome, we have our oral microbiome. There's even an eye microbiome. So and it just keeps going and going and going. Outside of our bodies, there's, I think I might have already said, soil microbiomes. There's people who are now doing like astro microbiome work, which is a thing. Point being is that there are a lot of different areas that you can just toss biome afterwards, and that'd be totally accurate. And it's really exciting to see people do more and more with this, because there are a lot of implications. Like a lot of what I'm seeing and I'm sure we're all seeing in the media, or even in a lot of scientific literature being reported, are research ideas or conclusions, et cetera, that are being made about the human microbiome in some capacity. And that's really exciting. And, hopefully there can be some benefit to human health from those findings. But I remember one of the first like microbiomes that I was actually really interested in was, it's going to sound really weird, but it was from like, it was because of, okay, I'll get to the end of it. I'll get to the end of it before I say the thing that's going to make me sound insane. Okay, so basically, when we think about like environmental science and climate change, like there are a lot of factors at play there, but one is methane emissions. That's a huge driver of climate change. And so the gross thing was, as many of us may or may not know, a lot of methane is coming from cow excrement.
Yes.
So as a result, a lot of farms, the like soil microbiomes there are like, they're producing a ton of methane. And it's like, okay, what do we do about that? Like, what reasonable interventions can happen here? And so there are a few, sources of methane production, but one of those, if we're like talking about bacteria, which was my interest, is species that are classified as methanogens. So they generate methane, methanogen. But there are also methane consuming bacteria. And those can kind of like, there can be a little interplay there, and there can be interventions that happen as a result of that. So circling this all back to where I started before, I didn't want to talk about cow excrement directly. I worked with human excrement, and that was fine, but cows, that's gross, I guess. Point of all of that being is there are a lot of different microbiomes, and the research that is being done within each of those can have a lot of different implications. And I think that is fun and exciting and relevant as the human microbiome related research is. We'd be limiting ourselves to not be excited about these other areas as well.
No, 100%. Yeah. I think I've heard about like the cow excrement kind of like idea. I think the idea, right, is that you want to kind of like maybe engineer those methane consuming bacteria, right, to try to like counteract all of the methane that's being excreted by our cow friends, right? That'd be good. It would reduce a lot, hopefully.
Hopefully, or at least neutralize, maybe. I don't know, but
worth looking into.
Yeah, definitely.
And it draws to, I think, a bigger point as well on a microbiome is how different types of cells interact with each other to make up that environment. So whether you're maybe adding more cells somehow to that pack of methane emitting cells to reduce the amount of methane, you're altering that microbiome.
I mean,
accordingly to meet that goal.
To try to, yeah. I mean, there's only so much intervention that you can throw in because, you were talking about earlier, Natalie, that sometimes these cells are interacting with each other, and that can be in unpredictable ways. And, certain expressions that we're expecting from those intervention methods might not happen in a given environment because of everything else that's there. And there could be some crosstalk happening. So it's cool. And so like microbiomes as a whole, like that's kind of just talking about like a neighborhood, if you will. Okay.
Yeah.
Microbiomes and neighborhoods are kind of like, they're communities. That's the best way to put it. I think they are communities, and yes, they can be altered for better or for worse. But they just exist as communities in one way or another.
I'm imagining like neighborhood drama, like like maybe one family gets kicked out for some reason, or
the HOA is mad at them.
HOA is mad. Or maybe there's like another family that helps out, a family that has just arrived and helps them thrive. There are so many analogies you can draw.
Absolutely. Yeah, that's a good one. I like that.
Thank you. Yeah.
This is the reality TV we need.
Microbiome.
Oh my god, yes.
And you bring up the point of community, and I think that draws to, I would argue the most important underscoring message of this entire episode is that not all bacteria are bad. Not all microbes are bad. You need diverse communities in order to have bodily function and for things to like go well for you, or else, if you have and I'm no doctor, right? That's no secret, but
just disclaimer, none of us are doctors or medical professionals. So keep that in mind, listeners.
But you can get really sick when your microbiome is all out of whack, whether it's your gut, your eye, whatever.
Yeah, and I think a great example of that a lot of people face is, we talk about like traveler's diarrhea, Okay, so when you go somewhere new, and like this is such a real thing, and
yeah, sorry, I don't know why I'm laughing. I don't.
It's when people
Maya, grow up.
I'm sorry.
Well, that's why I said cow excrement. Okay, but when you go traveling and you've just started eating a diet of a ton of different things that are being processed in a different way, than what you're used to, people do get pretty sick, or they can get pretty sick, and that is such a great example of, tossing something into the community, whether that is an introduction of, and I'm now kind of focusing in on the gut microbiome. So if you're throwing in different bacterial species that are maybe nice opportunistic pathogens, little bad guys who are taking advantage of a good situation, or if certain chemicals that are in some water that you're having, like that can throw you off too, and a lot of that is a result of your gut or other systems of your body being in some level of dysbiosis.
What is dysbiosis?
So when we think of, that's a great question. So dysbiosis doesn't sound pleasant, right? Because it's not. When we, I'm sorry, I'm looking at Natalie.
No, that was perfect, because it's not.
It's not.
Facts only.
When we think about the word, and I'm no entomologist, and I hope that's the word for people who know about words. But when we think about like the root of the word disease, or like if you break down that word, it's dis-ease, okay? It's the same with dysbiosis. It is a not optimal, we're going to just go with not optimal so that I don't like misspeak too much there, not optimal state of equilibrium in a given environment, or in a different like microbiological environment of your microbiome in this particular instance. So yeah.
So this is what leads your kind of like maybe gut microbiome in this example to be thrown like out of whack, and then you don't feel well.
Yeah, so that is, it's more so that's the dysbiosis is the state of that.
Oh,
it's
the
not,
state. Okay.
Yeah. It's not as much as like something happens that leads to dysbiosis. And that could be a disease that you have, or if food poisoning. Like it could be a couple of different things.
And why would you say it's important to have a diverse range of strains in a given microbiome environment?
Okay, so the analogy that I'll make for that one is, think about like a group project in school. And the very best case scenario is you have like a solid number of people in that group who are all bringing something different to the table, and they're all working in harmony with each other, and they have this really great end product. Okay, I think like that's an optimal situation for that group project. But if you think about that in terms of the different species of bacteria that you have, it's kind of the same thing. If you have a bunch of people in that group who are slacking off, just like not showing up, whatever, you're going to get to that end product, but it's going to be pretty sluggish along the way. Same thing with your gut. Or if you have people who are coming in, editing all of your documents and slandering you, then you are going to have a bad time. And it's the same thing with your gut. If you just have like the majority of that group being all of these pathogens, or we'll just go with pathogens for that, then you are going to be having a bad time. So I think that's the best analogy I can make there. And that's why you want to have that diverse community of bacteria. And there are some optimal levels for different types, absolutely, but that's way beyond the scope of what we need to get into for this conversation. But at the end of the day, there is a variety.
Let me know if I'm thinking about this the wrong way, but you mentioned that, say you go to a foreign country for the first time and you eat food that you're not typically eating, or you're drinking water from a source that you typically don't drink water from. That's kind of like having that editor come in when you've got everything working all in harmony, and then you throw a variable in there that your body isn't necessarily used to, that's where sickness comes in. And nobody else who is from that area or is familiar with that food is getting sick because that organism is part of their microbiome.
Yeah.
They've been working with that editor for a while.
They know how to deal with that editor. Yeah. I would say that would be an accurate description of that, because it's, you might be fine, right? But you also might not be. And I also want to just make a quick distinction that, like, if you're having all of these different bacteria, it's not bad. It's really not bad at all to introduce different types of bacteria in one way or another. I say to, like, I know a bunch of people who have kids under like the age of 5, and like right before they were all born, they're like, oh, new parent advice, blah blah blah, and I'm like, literally, let them eat dirt. Let them eat dirt. You want that kind of exposure, and that's an important thing to have throughout the rest of your life, is exposure to different bacteria and many other things. So my point is that, just the exposure to different things alone, that's not bad at all. It's when it's something in excess that has a negative outcome, or if you're introducing, like, obviously, if you're introducing like a disease, that's a kind of a more obvious one, but definitely would be the case too.
And I was curious about when we were speaking about the different kinds, like having a great big diversity of bacteria in your gut is beneficial. So what are some examples of the good kinds that we can have inside us? Do you have any favorites?
I have so many favorite bacteria. It's ridiculous. I think that I'm going to give like 2 classes of examples, because you can't just go out to the store and buy any bacteria, like, when I say that, I know, darn, I wish I could.
Oh, darn.
Like,
bacteria store. They sell them at CVS.
Well, but they do sell probiotics, right? And so, like,
True.
that's more so what I'm saying is, like, yeah, there's some that you can go out and you can purchase a probiotic for, and you can have a little dose of that and introduce it. And so, like, that's available to a consumer. They're not all. So I'm gonna give examples of some of my favorites for both of those. And I am gonna give their big old scientific names too, because I like saying them. Yeah. So there are a few that are really common in the development of different food products. So like yogurt, that I feel like yogurt is the one that we think of the most when we're like, oh, I'm gonna go get a probiotic food. And so we'll stick with that. But one is, and I wrote down a little notes about these guys too. And so, quick disclaimer with all of the ones that I'm going to list for, ones that you can get. Generally speaking, like, these are like positive indications from them. It's not going to be curing everything. It's just, that's unrealistic. Talk to your doctor if you need to be cured of things. Anyway, don't eat yogurt.
Talk to us.
Don't eat yogurt to cure your IBS. That is not what I'm saying. Speaking of IBS, though, one of a really, really common bacteria that's used in yogurt blends, in like probiotic pill blends, or just it can be sold on its own as well, is Lactobacillus acidophilus. It has indications in alleviating some IBS, and that's why I just brought up IBS, some IBS symptoms and disease markers, as well as allergy, and a whole range of allergies. So I'm not going to get too specific there, but like, so a lot of that mechanism of action is coming down to reducing inflammation and inflammation states. And so that bacteria on its own, it has been shown to do that. Again, I'm not saying that eating yogurt is going to cure you of those things. I just want that very clear. Another really common one is Bifidobacterium. Also, Bifidobacterium, I have such a love-hate relationship with all of the Bifidobacteria, okay? Love it from a consumer standpoint, hate it from a researcher standpoint because it's annoying to work with. but it's really cute. Anyway, Bifidobacterium breve produces both acetic and lactic acid in your gut. And so that can kind of help with strengthening your intestinal barrier, which is that it's good to have a solid intestinal barrier. A lot of diseases kind of do come back to that in one way or another. Again, not saying that that's the cause of diseases, but caveats are important here because I'm not a medical professional. And the other thing with Bifidobacterium breve is it has been shown in more like lab specific studies to aid with certain levels of cognition.
Ooh.
That's more so in terms of like reduction of certain, let's say, processes that ultimately lead in symptoms of dementia. So again, isolated studies, that's just like a cute little thing about that one. So those guys are great. There are also some of these like consumer species that have been extremely well documented just in research. They're in like collections that anybody can buy as a researcher and just do a ton of work with them. So they're awesome. That's lactobacillus okay, this is one thing about microbiology. This is a quick aside. One thing about microbiology is that the names for these bacteria change all the time into absolutely ridiculous variants of their original name. So, so this one that I was about to say, this is actually now Lactobacillus rhamnosus. And then I think I literally wrote down L and then species name. So that one, L, don't remember what they changed that one to. Paracasey, and then Bifidobacterium lactis. So those, again, are some of the most studied species that are also available to consume in one way or another. And they have some of the strongest recorded efficacy in studies against layers of dysbiosis and other infections. So those guys are all great and are often used for food production. Well, yeah, in certain types of food. But then I have some personal favorites that you can't get. I hope that someday you can. These definitely, especially this first one, falls into this like category of like next generation probiotics, hopefully, which is just new types of probiotics trying to come to the market. First one, Faecalibacterium prausnitzii. I love her so much. She's been one of my good favorite friends since 2019, partly because of the name. I'm not going to lie to you. But has a ton of benefits, but what those benefits like kind of all boil down to is the production of a short chain fatty acid that is there are a lot of short chain fatty acids, but this one in particular is butyrate. That has, not going into a lot of details there, a lot of anti-inflammatory properties, and it helps to enhance intestinal barrier function, which again, like I mentioned, that's really important for a lot of reasons. It also produces other types of bioactive anti-inflammatory molecules. But its biggest thing really is helping to protect that intestinal barrier.
Cool.
That one's hard to work with because it's very, very anaerobic. It does not like oxygen at all. So that's, but and a lot of people have that naturally, which is good. So I would say, and then one other that I wanted to plug is Prevotella histicola. That is one of the bacteria that I flagged a while ago in my head that I was like, this guy is so cool. It has shown pretty promising results in certain models of inflammation for rheumatoid arthritis and MS, specifically in animal models. So a lot of research is pointing to the idea that, okay, it's not out of the question that this could eventually be used as a therapeutic for suppressing these diseases in people, which are both like very debilitating, right? So like one area of, one aspect of like gut microbiome research right now that I'm seeing, and I'm feeling encouraged about in some capacity is, this kind of like honing in on anti-inflammatory things, because they can just inflammation leads to so much garbage, whether it's lifestyle or just, I don't know. But yeah, those are some of my favorite friends.
So cool. I feel like the future of probiotics seems very bright. I think I'll look forward to when we can see. I noticed that you left the name here. Faecalibacterium.
Faecalibacterium.
Faecalibacterium. Prausnitzii?
You got it. Yes.
Oh, it's a cool name. I'm looking. Thank you. I'm looking forward to seeing her on the shelves.
I am too. I really am.
Well, we've talked about a lot of things today, but before we bid you adieu and bid the listeners adieu, what is something that you wish more people knew about microbiology?
I will talk about, I don't know how many things I'll talk about here. I hope not too many. These are things that I get excited about. So one, just kind of specifically about the microbiome and our gut microbiome. I was just talking about these probiotics that you could potentially go to CVS and purchase, and that's all well and good, but I don't think that people should think that is you have to go and do that. And there's a lot of gut health supplements out there that, while I wouldn't say that they would be doing you much harm, I would hate for somebody to think, okay, I need to do this in order to stay healthy. I need to spend all this money, blah, blah, blah. You don't need to do all of that. If it's something you want to do and that brings you joy, I have done that plenty of times as well. What the most important thing you can do for your gut and to kind of encourage symbiosis, which is the opposite of dysbiosis, little vocab plug there. The most important thing you can do is have a nice well-rounded diet with lots of fruits and veggies in particular. When those are broken down in your gut, they produce basically food for your bacteria. If you hear the term prebiotic in the media or marketing or whatever, it's food for your bacteria in a couple of different ways. But your bacteria are then able to eat up that stuff and produce certain things that lead to hopefully positive outcomes. So you don't need to go out and spend your paycheck on the supplements aisle in Whole Foods. If you do, just make sure you're listening to a doctor. So I would say that. Regarding microbiology as a whole, I think especially in the recent years, and I fall into this as well. I'm a germaphobe, and it's funny that I am, and that I've done so much work in this field to be complete. It's funny. And this is one thing I tell myself all the time. It's okay, not all germs are bad. And this is how I kind of explain a lot of this stuff to some of the kids in my life, because they're you work with germs? I'm yeah, I do, but they're not all bad. They're literally fine sometimes. And so, just practicing for those of those listeners out there who do maybe struggle with the concept of all germs are bad, or I can't even say specifics, because then I'll just be I don't know, I'll start laughing at myself. I'm very much a no outdoor shoes inside person. I'm very about that. When it comes down to it, though, it's okay. It's okay. It's a little yucky. It's a lot of it yucky. But it's okay. We shouldn't be so fearful of the world around us, because like I said earlier, having a diverse set of good and bad, potentially bad, organisms in all of our microbiomes, that is good, and that is what we're supposed to have. So microbiology is also just really cool. If you have ever thought about learning more about it, you should. It's awesome. There are so many good online resources, and check out that agar art competition. That is it's just so pretty. It's so pretty. So yeah.
Yay. Yeah, we should
Amazing.
definitely link the agar art. Please send us the link, Bridget, so we can share it with the world.
I will.
Well, thank you so much for coming on the show, Bridget. This was a blast. I felt like we just laughed the whole time. I had a really fun time with this episode.
This was so fun.
It was great.
So glad to hear it. Listeners, you can find us at interactome_media on Instagram or at the Interactome on Twitter, now X, whatever you call it. And we'll catch you in the next one.
Thank you, Bridget.
Thank you, guys.